We graph number 2, I'm just going to use our calculator and put our x1 and y1 in. Make sure we change our parameters from -1 to 1.5. And if we look at the graph, we end up getting the same graph as before. All right, we get the same graph as problem number 1. Alright, well, we end up getting the same graph as number 1. But there's a big difference, right? Our equations are different here. So this is where, what we talked about with parametric equations, that t gives us more information. Even though these are two completely different equations, two different sets of parameters, we get the same graph. They both tell a different story. So let me give you an example. Who is a cross-country person in here? I know we've got some. Megan. All right, Megan. Let's say Megan is running a race for cross-country. And this graph basically represents that path. This is her starting point. This is her ending point. Right? So if two different people run the same path, they're taking the same path. So it's going to look the same as a graph. But if we talk about how much time it took Megan to run the race, or where she is at a particular time, this parametric equation is going to help tell that. So, to give you an example, if we were looking at these two equations, equation number 1 would be Mr. Mitchell, equation number 2 would be Megan, because if you look, Megan completed the same path in half the time. Right? So here, this goes from -2 to 3. This is going from -1 to 3/2. This is like half the time as it took for this one. So although the graphs look the same, the situations are very different. Right? So that's where parametric equations can be pretty helpful with that extra parameter.